Hey, this is a demo of how Overmind interacts with Kubernetes. So you might be familiar with how Overmind can find the dependencies within your AWS environment. And we can see this is exactly what it's doing here. I've told it to go and find everything it can within my AWS account. But we also support Kubernetes, and we discover resources inside of Kubernetes clusters in the exact same way that we do inside of AWS. So we reach out to the API in real time, we find those resources, and then we find all of the dependencies of those resources. If I was to look, and if we look at this graph here, there is actually some Kubernetes stuff in here and some AWS stuff that is linked together, and we don't differentiate them mostly. The Overmind is able to handle them as if they were equals, and you'll see why we do it that way in a second. So let me just clear this and start again. And I'm going to look for a deployment called API server. Now this is a Kubernetes deployment, and we can see it's able to find it. So this is the deployment on the dog food cluster in the default namespace. If I expand this deployment, it finds everything that's related to that. There's a bunch of replica sets. A lot of them are not used. This one is. This replica set has a single pod running. If I was to expand that pod, I get all of the things that are related to that pod. So it's got a service account, it's got some secrets and config maps, endpoints, persistent volume claims, etc. I can expand the persistent volume claim to get a persistent volume. From a persistent volume, I can get the storage class that the volume is related to, and all of these things are Kubernetes resources. However, this one isn't. This is an EFS access point from AWS, and you can tell because the scope is the AWS account in the region rather than being the cluster. And so this has actually looked up the AWS API to get the information about this access point because it knows that this is the access point that backs this particular persistent volume. We can expand then inside the access point, and now we're going to be hitting the AWS API. So there's a file system that backs that up. If I expand the file system, there's a whole bunch of stuff related to that, a mount target, a whole bunch of mount targets, a backup policy, all that sort of stuff. So because we treat these things, Kubernetes resources, AWS resources, etc., as equals, we're able to link from the AWS resources to the Kubernetes resources, even when you wouldn't be able to otherwise. So for example, if you look in the AWS GUI at this access point, you don't get much information. This is what you get from the API. It kind of references that it's a PVC in here and in here, but it's not actually enough information to find which persistent volume this backs. And so if you were to make a change to this file system, there's no way, in AWS at least, to work out what that is going to affect. Whereas because Overmind understands these relationships, if you were to make a change to this file system, we would be able to tell you which pods mount persistent volume claims that come from persistent volumes that come from access points which are backed by this file system, and therefore what the blast radius might be. It doesn't just work with file systems. We can expand onto, we've worked out that this pod has an IP address. If we look at this IP address, there is a load balancer target pointing at it. If we expand that, we should be able to see a little more, but we'll stick with this for now. So this load balancer target is pointed at an IP. Once again, if you looked at this in AWS, you would just get an IP address, no further information. It doesn't tell you what pod it is, but because we know that this IP is in use by this pod, we can go through and do the expansion. And so this is how we calculate blast radius and then calculate risks but inside of Kubernetes. If you're changing a Kubernetes resource, we start there and expand out. If you're changing an AWS resource, we start there and expand out. But we're always able to link from one to the other. So if you're changing an EC2 instance that happens to be a node in a cluster, it's going to be able to work that out, and it's going to be able to tell you which applications within that cluster are likely to be affected. If we were to look at a change that actually did affect something in Kubernetes, we can see here what I mean. So this is a change where we're changing a secret and a deployment. If I look at the blast radius, we can see it's been able to discover quite a lot of information from just those two starting points. We've got, if we look in here, we've got some more deployments, endpoints, pods, other things that we think might be affected. It's also identified the risks. If we zoom in here, the proposed update to this secret suggests removing the data from the secret configuration. Given that it's utilized by the front end application for sensitive configurations like authentication details and API keys, its modification could disrupt authentication flows and API communications, ultimately degrading the user experience. This modification could cause an impact on app.overmind.tech endpoint, leading to failures or API access issues. So because we know that this secret is used in this pod, we know the load balancers that this pod sits behind, we know the other things that it communicates with because we can see the communication, where the config, we're able to give you a risk that is this specific. It's telling you exactly which app is going to be affected, which in this case is Overmind itself, because it's able to traverse from the secret to the pod to the load balancers, even though they're in AWS.